Thanks for tuning in, everyone. Today's a really special day for my channel because it's the first car that I've designed myself, that I put into 1/64 scale form. I've done a lot of wheel mods and stuff like that, but I actually designed a supercar back like 20 years ago when I was a student. And now that I have a 3D printer, I thought it'd probably be smart to actually try to print it out in the real world instead of it just existing in a digital file folder as sketches and stuff like that. So before I go into showing the model, of course, I want to talk about how this model came about, because I would have never made this model if I didn't see the recent Lamborghini Gran Turismo Vision concept car. A lot of the styling elements of that reminded me of what I designed a long time ago. But anyways, this first image, if you're unfamiliar, this is a McLaren F1, and I think this is the greatest production road car ever made. It was designed by Gordon Murray, who was thinking along the same lines as the founder of Lotus, Colin Chapman. And both of these gentlemen's design thinking is to be as lightweight as possible, because lighter things have less inertia. Lighter things can turn faster, they can brake quicker, they can just change movements quicker, and they're less taxing on their tires, brake systems. Everything can be lighter and handle better, basically. It's kind of like riding a bicycle. If you ever ride like a modern bicycle that weighs less than like 10 pounds, 15 pounds, but then you ride a 50-pound old Schwinn, you can immediately tell the difference, right? So I believe in the same way as these guys, things that are lighter and are better, I suppose. Okay, so now you guys probably know the McLaren F1, but Gordon Murray also designed this car here. It's called the Rocket. And I guess only 50 of these were made, so very limited. And you'll see here, there's a Jay Leno. He has a great video on this because he owns this car, of course. He owns almost every cool car. And this is, I think, the lightest production road car ever made. It's like 700 pounds or something like that. It's powered by a motorcycle engine. So again, lightness is key. But anyway, so these two cars, the McLaren F1 and the Rocket, both designed by Gordon Murray, were inspiration for the car that I designed when I was a kid. So usually when you design a vehicle, you find some sort of inspiration, and in my case I was thinking about things that go fast. And things that go fast, you usually think about birds and stuff like that, but I think about the water. The reason why is because the water is a much more viscous, thicker material, so things that can swim fast, I think, are probably designed better than things that can fly fast. Maybe I'm wrong, I'm not an aerodynamicist or a biologist or anything like that, but that's just my thinking. Okay, so anyways, I took a few classes there at school. If you're curious, the school is called Art Center College of Design. It's in Pasadena, California. And so you take all these classes there. So these are some digital models I was thinking early on. Basically, they're single-seater, street-legal cars is what I'm thinking. There's a little painting that I did horribly. Then I get to some sketches here. This is like a weird double-decker diffuser belly pan / upper wing idea. It's a rear view, and then here's another rear view, but now it's more organic, more like aquatic, I suppose, kind of like a stingray or a manta ray. Here's another one as well, and you'll see the rear is much thinner than the rear wheels. And so my thinking is tapered designs, like a tuna fish. Those things swim extremely fast. Or bullets, they're tapered a little bit in the rear, unless it has a cam tail, but that's a different story. So anyways, yeah, here's some other ideas, some ideation, and some packaging. You can see like this line drawing in the middle. You want to package a vehicle around the driver and the engine components and stuff like that. So there's some ideas. And then I finally got to refining it, and these blue sketches you see at the top are the direction I was going for. You notice in the headlight, it doesn't have normal lights. It's supposed to be like a large round like fiber optic rod, and that's supposed to illuminate the light bucket. There's two wings in the front, and then the suspension components are airfoils as well, so everything basically is trying to provide downforce. Okay, so that's what's going on there. So after you do some drawings, we make clay models. This is a 1/5 scale clay model. This thing probably cost like $500 to make, just to let you know. Design school isn't cheap. But this is a huge model. It also probably weighed like 30-40 pounds when I was done, and I only made half of it. It's actually pushed up against a mirror to mimic a full-size car. You know, if it's against a mirror, it's perfectly symmetric if you only make half of it. So after the molding in clay and stuff like that, you paint it, you know, with real automotive paint and automotive primer and stuff. And because this is supposed to be a McLaren, it's painted in orange. And yeah, that's pretty much it. It took a long time, of course, to do all this stuff. And one design feature I really wanted to go with were perimeter brakes. You don't really see it in automobiles too often because it would be really difficult to remove the wheel. But there was an old American motorcycle company called Buell, and Eric Buell had perimeter brakes on his motorcycles at the time. So I really enjoyed his design thinking in his motorbikes. Unfortunately, I don't think they did too well because they're powered by Harley-Davidson engines. But anyways, the perimeter brake, the general essence is the rotor is attached to the wheel, and then the caliper is attached to the axle. So you basically have more sweeping surface, so the brakes don't overheat. You know, there's simply more surface area to dissipate the heat, and so that's why I like the idea of this. And essentially the concept of my car is to be a short track racer. So I'm calling this car the STR for Short Track Racer. It's meant for short racetrack courses, not particularly long Le Mans kind of things, you know. So it's just meant to be lightweight, it's meant to be nimble, and only one person is supposed to drive this, and primarily they're supposed to drive it on a racetrack for fun, but it's still street legal, so you can actually get to the racetrack instead of using a trailer. You'll see in this image here that I have, you know, the perimeter brakes, but you can kind of see the rod here in the back taillight section. You know, it's just like a large neon tube, or maybe it's filled with LEDs today. This is back 20 years ago, before LEDs were really common on headlights. So that's what's going on with the clay model that I made. But now that 20 years have passed, you know, I've made some changes to my design. But before I do that, it's an interesting story. Right after I finished making this model, the Caparo T1 came out, which is very similar in its design. You know, as you can see, I think. I don't think Caparo did well either. I think they may have gone out of business. But as I mentioned earlier, the reason why I decided to make this model in 1/64 scale is because I saw this Lamborghini Vision concept through my research after buying a bunch of those majorette Gran Turismo cars. And so I thought, well, part of that looks kind of familiar, and I didn't know why. And then I realized, yeah, I guess maybe some of it's familiar with the pontoon kind of fenders over the wheels, and then a bunch of air between, you know, the cockpit and the wheels, and the fact that it's a single seater. Now, of course, the Lambos are much more angular, you know, faceted kind of design language, whereas I was going for very organic. But still, I think it's a pretty cool car. I really wish someone would make this in 1/64 scale, you know, like maybe a high-end resin. I would definitely buy that. This looks a lot cooler than the Terzo Millennio that I reviewed a long time ago. Okay, so now I guess it's time to actually unveil the actual 1/64 scale model. It's actually made of resin, of course, because I have a resin 3D printer. And here it is. Okay, so here we go. Alright, so it's actually too heavy to spin on my solar spinner, so I just wanted to use this because I have this little display thing. Okay, let's take it off the this, and actually I'll show you the details in 1/64, what I was able to transfer or carry through from my idea, and as well as the changes I made from that original clay model I made like 20 years ago. Okay, so this time around I put the perimeter brakes on the outside. You know, the whole braking system is on the outside surface, so you can see it, whereas on that old clay model is on the inside. You can still see in the back there's a 5-spoke wheel back there, well, 5 spokes, and they're actually fan blades, so the intention is they actually suck air from the inside of the car and push it outwards to help cool off the brakes. And while I'm talking about the brakes, there's actually brake ducts here, you know, like an old F1 car right there, and then also right here in front in this fender here. So those are sending air, you know, around a 90-degree corner, and they help to cool off the brake calipers. That's the intention there. So the main issue as to why, you know, perimeter brakes don't exist on a regular car is because how would you remove the wheel if the caliper is attached to the chassis, right? So that's a big problem. But nowadays with electric motors, I think you could just remove the entire wheel assembly. The wheel, the tire, this whole brake system could be removed as one piece, and then that gets swapped out, say at a track event or something like that. This obviously would be a car meant for the very wealthiest of people, you know, so practicality isn't really a concern for me. This is just meant to be a very expensive hypercar, really. Okay, so yeah, obviously you got some huge rear wheels. I figured why not? They're also staggered tires. And back when I designed this car as a student, I thought it was being powered by a petrol engine. But now I think this would be powered by electric motors. But the motors would be within the body. And the reason why is if you go to the top view here, the body is extremely narrow. It's like a fish. So you'll have one person sitting here, and then it tapers off, of course. And so there still has to have drive wheels here. I mean drive shafts, front and back, so that because the motors are inside the body here. Okay, so we're at the top here. Here's a vent to help cool off the rear motors, or maybe it's one motor and then a transfer case or a differential or something. This is a fantasy car, guys. I can make up anything I want. Okay, so let's see, going to the top rear, there's going to be 5 LEDs up here. These would be the third brake light system. And so the intention would be, if you're lightly braking, maybe the center LED lights up. If you're braking medium level, 3 light up. And then if you're hard braking, all 5 of these LEDs would light up. So it'd be like a progressive braking light indicators. This is a grill. So the capillary action of the air flowing over this body would help suck the air out here and help cool off, the batteries as well as the motors and any other electronics that get hot. Okay, so unlike the clay model I made, I changed the lights over to like LED projector styles, at least projectors in the front, and then just LEDs in the rear. So it's kind of like an octopus kind of styling now. Still marine, still organic, just no longer rods. And so partially because it would be really boring to just have a stripe of red like I did on the clay model. So I think this is kind of an interesting evolution from my original design. Okay, here's another cooling duct here to go into the rear. I put charge and computer telemetry ports here on both sides of the car, so you can charge the batteries or plug in for race analysis or whatnot. Radiators would be here, a radiator here and a radiator on both sides, and these are the exhaust for it. So the front, I changed from the acrylic rods to these projector styles. So headlight, turn signal, and auxiliary lights, fog lights or something like that. This probe here is supposed to be an airspeed sensor, kind of like on the front of an airplane. Why not, right? Okay, so a couple more vents here. Not quite NACA ducts, but they're along the same line. And so again, that's to help cool off the 2 motors that would be sitting right around there. And then you can kind of see that darkness there. That's where the air would go to cool off the radiators. Here's a little vent here for the driver to get a little fresh air, because most likely you'd probably be wearing a helmet on a racetrack, and so it's going to get really hot. Okay, so on this car I removed the double-decker wing, because now with active aerodynamics, I figured why wouldn't this car have active aero? So I actually painted this part black. These would be flaps. You can maybe see from the side view a little bit. Right now it is sticking up a little bit, and the intention is to kick up a little bit of air so it clears that lower suspension and helps feed into the radiator. Or at a high speed it'll kick up the air enough that it might clear all of that and go over the top of the vehicle, or the top side here. But anyways, being active aero, if it needs to brake or create more downforce in a turn, one of these flaps or both of these flaps would actually pop up to create that downforce that's necessary. Alright, so the cockpit itself, it's like a airplane style. It's just one giant, canopy, but it has 4 windows. and it would tilt forward. So here's the hand grab there. You grab it with your hand, there'd be a button there, and you pop in. And so knowing that you'd have to actually probably drag your feet or your sneakers over this thing, this little panel here and on the other side are supposed to be inserted either rubber mats or some sort of sacrificial material. Maybe they'd be carbon fiber, but the key is you can remove them, so if you scratch them up, you can just pop in a new one, because you're always going to be messing around with this. Or maybe you literally can stand on this and then try to get into the center cockpit there. Alright, so yeah, the second side, you got the ports there, the radiator there, the vent, the rear vent. Okay, and then yeah, little cutouts here. This section of these rear wings would be active aero, so if they need to brake or again create more downforce, they could raise up raise up, or at super high speed, maybe it's creating too much downforce, they could actually tilt down to create less drag. Alright, so I think that's everything. There's a little bit of a logo, but there's supposed to be a vent in here. The bottom is rough because I have a resin printer. There was like 6 million little support struts that I had to clip off and then sand, but that's unfortunately the sacrifice you make with a cheap resin printer. If this was printed with SLA, like SLA laser sintering, it wouldn't have any of that, but I don't have a machine like that. So okay, I think that's everything. That's another vent there to help cool off that back area. Yeah, okay, so let's put it up on the dyno. My dyno diorama isn't so heavy that the car could actually probably spin on this one. So I originally designed this car around the McLaren F1's packaging, meaning the wheelbase and the driver and the engine and all that stuff. So I think it would be logical to actually put this up here and compare it to that. And the other thing it would be comparable to today would probably be an F1 car. Okay, so I guess the top view would be better for you guys. You can get a general idea of its length and its width. It's relatively similar to the other vehicles, right? But it's basically a road legal F1 car with a roof, so you can drive it in the rain. That's essentially what I'm going for. And its styling, elements are more organic and oceanic, I suppose you could call it, versus angular and faceted like a stealth fighter. Okay, so it was I'm not gonna lie to you, it was quite a difficult project. It took a long time for me to model it in my CAD program, maybe 30-50 hours, and I have over 10,000 hours of experience using a CAD program, so I guess I'm relatively good at a CAD program, but it's still not easy to design a car in a computer. If it was easy, I think more people would do it, but I was kind of bored. It's this whole COVID thing. I am stuck indoors and avoiding death outside, so I figured why not? Now they have a printer, a 3D printer, I can do these sort of things. Maybe later I'll even design an SUV I was thinking about, and I also have a like a treaded snow motorcycle, and I do have a 10 scale model of that, but I've never bothered to show it on this video because it's been broken several times. My cat knocked it off the shelf and stuff, but maybe I'll actually see if I can print it in 1/64 later. But we'll see. Again, it's a very time consuming process doing this sort of stuff. But if you watch this video, I appreciate you guys checking in, and let me know what you guys think. It's a very bold color choice. I'm going for McLaren orange. That's why it's colored orange, because I just love the McLaren F1 and the rocket. I really wish the Gordon Murray rocket was made in a 1/64 scale. I've seen some models that have been 1/43 scale, by the way. If you guys like that car, it does exist in 1/43. It just doesn't exist in 1/64. Oh boy, that's just now making me think, should I make one of those? I don't know, we'll see. Okay, well anyways, yeah, thanks for chiming in, and we'll get back to regular scheduled reviews later on. Thanks.